All right, you guys, so here is the answers for FRQ number 4. I skipped number 3 since we did it in class. Okay, so for part A, you have that xy squared minus x cubed y equals 6. And you're trying to show that dy dx equals that. So I'm going to use implicit differentiation here. Super important that you show all of your work, okay? So the first thing I notice is that this first part is a product rule. So I'm going to do the derivative of the first times the second plus the first times the derivative of the second. So the derivative of y squared is 2y, but don't forget to tag on that dy dx. Okay? And then I have minus. Now, hey, a little hint here. If you're subtracting and then you're doing a product rule afterwards, put parentheses here, okay? That'll really help you not lose the negative sign. Okay, so I have another product rule. So it's the derivative of the first, which is 3x squared, times the second, which is y, plus the first, which is x cubed, and then times the derivative of the second, which is dy dx. And then be careful on this part too, the derivative of 6 is just a big fat 0. Okay, so that would get you a lot of points, but let's see if we can get to that answer. So let's do a little bit of cleanup here. 1 times y squared is y squared. Then we have 2 times xy, that's 2xy dy dx. And I'm going to go ahead and distribute that negative sign through. So I'm going to have negative 3x squared y. And then a negative times a positive is going to be a positive x cubed dy dx, and then it equals 0. Okay, now remember, I want everything that has a dy dx to stay, so these get to stay. So let's go ahead and rewrite those. So I have 2xy dy dx plus x cubed dy dx. And that's going to equal, so look, this guy needs to move. It's positive on the left, so it's going to be negative on the right. And then this guy also needs to move. It's negative on the left, so it's going to be positive on the right. Okay, now if I factor out that dy dx and divide, you're going to get that dy dx is negative y squared plus 3x squared y all over 2xy plus x cubed. Now, let's look how close we got to the answer, okay? So the answer was 3x squared y minus y squared. So it looks like they flipped this around, which is totally fine, over 2xy minus x cubed. How did I not get a minus in there? Did I copy over wrong? Why do I have a plus x cubed? 2xy... Oh, I see my mistake. Do you guys see that? I didn't distribute my negative sign. Silly me. Look, a negative times a positive here. This should be a negative. So there's my little mistake. Okay, which means that this should be a negative and that this should be a negative here when you're dividing by the x cubed. Okay, so then this, if you flip this around, you get 3x squared y minus y squared all over 2xy minus x cubed. Now you guys, look, in a way I'm kind of glad that I made a mistake somewhere, because what you don't want to do is go, oh, it should be a minus, and just change it to a minus without fixing like why it should be a minus. Does that make sense? Because for this one, I do actually look at all the work. So if the work doesn't correspond to your answer, you don't get the points. Okay, so here's part A. Now part B says, okay, let's look at part B. It says find all the points on the curve whose x-coordinate is 1, okay? So that's the first part. I have to find all the points on the curve whose x-coordinate is 1. So points on the curve. Who's the curve? This is the curve. And I want to find all the points where x equals 1. So that just literally means plug in x equals 1 and find y. Okay, so let's write down the equation again. I have xy squared minus x cubed y equals 6. And I want x to equal 1, okay? So if I plug x equals 1 into my equation, I'm going to get 1 times y squared minus 1 cubed times y equals 6, okay? Which is really y squared minus y equals 6, okay? Now, how do you solve an equation like that? It's a quadratic, so I have to set it equal to 0. And then I'm going to go ahead and factor. So some algebra here. I need two numbers that multiply to give me -6, add to give me -1. That's going to be -3 and 2. So this is going to be y minus 3 times y plus 2 equals 0. So my two y values here are going to be y equals 3 and y equals -2. So look, when x equals 1, here's my first answer for this part. When x equals 1, one y value is going to equal 3. And when x equals 1, another y value is going to equal -2. So I just answered the first part of the question, right? That said, find the points on the curve whose x coordinate is 1. So it's 3 and -2 like I found there. And you should really write it as a point. I got kind of lazy writing the answer. Okay? Now it says write an equation for the tangent line at each of these points. So look, I have to write two tangent lines. So let's look at this. I have a point and I have a slope. So one point that they gave me is this 1, 3. That's one point that I found, right? So let's do it for that one. This is the point 1, 3. Now I need to find the slope at that point. You guys remember this right here was your slope. So let's take this x squared y, 3x squared y, sorry, minus y squared over 2xy minus x cubed. And let's plug in that x equals 1 and y equals 3 and see what we get for our slope. So this is going to be 3 times 1 squared times 3 minus 3 squared all over 2 times 1 times 3 minus 3 cubed. Okay, so doing this is going to be 9 minus 9. Hey, that's a 0 on the top. It doesn't matter what this is. 0 over anything is 0. So I have a point and I have a slope. So how am I going to do this? It's going to be y minus y1 equals m times x minus x1. 0 times anything is 0. So if I have y minus 3 equals 0, one of my tangent lines is going to be y equals 3. Okay? Now, the issue is, though, that I have another point here. Sorry, there's a mosquito trying to attack me. Okay, the other point that I'm looking at is 1, -2. So I have to do the same thing with 1, -2. So here's my point. Now, my slope, again, is this 3x squared y minus y squared over 2xy minus y cubed, and I want to plug in this 1, -2 to find my slope, okay? So plugging this in, you're going to get 3 times 1 squared times -2 minus -2 squared all over 2 times 1 times -2 minus -2 cubed, okay? So all of this right here gives me -6 minus -2 squared is a 4. All over this part right here is a -4, and then minus -2 cubed is a -8, which is really a +8. So this is going to be -10 over 4, which is -5 over 2. Okay, so if you look at the other one, how did I get 2 for this? Oh my gosh, did I plug it in wrong? Hang on a second. Let's see, it's -6. Did I plug it in right? 3x squared y minus y squared over 2xy. Oh, here's the problem. You guys, the slope is x cubed. Look what I did right there. I put a y cubed. Okay, do you see the stupid mistakes that you can make on this? Okay, so that changes this number right here. This should be my x value, so that changes this to a 1, which means this is going to be a -1, and -4 minus 1 is -5. So that works out. -10 divided by -5 is just a +2, so your slope is 2. All right, so plugging this in into point slope form, you're going to get y minus y1, which is +2, equals m times x minus x1. Okay, and you guys, honestly, for a mistake like that, you'd probably just get docked 1 point, so it's not the end of the world. But notice how easy it is to make mistakes, right? Because there's like x's and y's flying all around the place. All right, now part D, what does that ask me to do? Find the x coordinate of each point on the curve where the tangent line is vertical. Okay, tangent line vertical means that the line goes up and down, which means that the slope is undefined, which means that your derivative is undefined, which means that the bottom part of the derivative must equal 0. Okay, so let's look at this. I want the bottom part of the derivative, which is this right here, right? Let me highlight that in a different color. Actually, let me do this. I want this part here to equal 0. So I want 2xy minus x cubed to equal 0. So let's write that down. So for part D, or C, I want 2xy minus x cubed to equal 0. Now, who's this easy to solve for? I'm going to go for y this time, okay? So I'm going to go ahead and add x cubed to both sides. And then I'm going to divide both sides by 2x. Okay, so you're going to get y equals, one of the x's cancels out, so you're going to get x squared over 2. And I'm going to put this in a little bubble, okay? Now, what do I do with at y equals x squared over 2? I'm going to plug into my original equation, okay? You do it in a different color so it pops a little bit. The original equation was this xy squared minus x cubed y equals 6. So I have xy squared minus x cubed y equals 6. Hey, but I'm going to check it one more time to make sure it's right. Xy squared. I feel like I'm having like little silly issues all over the place. Okay, so it wants me to replace all the y values with x squared over 2. So wherever I see a y, I'm going to plug in an x squared over 2. So let's do it. X times x squared over 2 squared minus x cubed times x squared over 2 equals 6. So I need to solve this equation for x. This is going to be fun. So this is x times, if I square this, I'm going to get x to the 4th over 4 minus, I'm combining these together, that's x to the 5th over 2 equals 6. Multiplying this out, that's x to the 5th over 4 minus x to the 5th over 2 equals 6. Now, you guys, you can do like common denominator here if you want to. The common denominator is 4, so let's give both of these a 2. So that would be x to the 5th over 4 minus 2x to the 5th over 4 equals 6, okay? And you guys, since the common denominator is 4, you have 1x to the 5th minus 2x to the 5th, which is negative x to the 5th equals 6. Multiplying both sides by 4, you're going to get negative x to the 5th equals 24. Divide by a negative, and then take the 5th root. Oh my gosh, and you guys, that was the right answer, but it is as ugly as it can possibly get. All right, so that's number 4. Let me start a new one and do number 5.